الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله. Yes, last thing I talked about was in chapter 11, and last thing I talked about was the properties of liquid. Okay, let's go. Bismillah. What is the meaning of surface tension? Can you see the
التوتر السطحي.
can you see the screen?
Yes, yes, we can.
Good.
Yes.
Good. Now, what's the surface tension? I want everybody to participate. Go ahead.
The attraction between the same molecules of the subject.
Okay, why we call it surface tension?
Happens on
It
the
happens on the surface of the liquid.
But inside the surface, why here it's not happening? Why?
Because of the forces from everywhere, from up, down, right, left.
Yes,
Cancelling.
there are forces from the upper side.
Cancel each other, right?
Yes,
Okay,
Yeah.
but on the surface, what will happen?
they will not cancel.
They will cancel from this side and this side. But how about from this side?
Upper side is open.
That's
Has-
open. Yeah, that's the meaning of surface tension. It's the attraction between what? The liquid molecules. Okay, good. Next, what is capillary? What's capillary? Hello.
هي الظاهرة اللي تحصل لما يصير مقعر في التيوب.
No. Capillary means what happens when we have very thin tube. Capillary means very thin tube. That's why the meaning of capillary is thin tube. What's the capillary action? Look at the picture. What's happening here?
Rising the blood.
What?
Blood
going
is
up.
rising up.
This is called when the blood rise up like this is called capillary action. That's the meaning of capillary action. The blood is rising in the tube. Okay. What causes capillary action?
Adhesion.
Yes, adhesion. Excellent. Adhesion is the reason. Yes. What's adhesion?
Attraction between unlike molecules.
Unlike molecules, in that case, the surface of the tube and the blood.
Exactly. So it is the liquid molecule with what?
With the tube surface.
With the tube.
Tube molecules. But what's cohesion then?
Attraction
Same.
between the liquid.
Like
Liquid
molecules,
and-
so liquid and liquid.
Liquid and liquid
Liquid and
molecules.
liquid, yeah.
The same liquid molecules. Same liquid molecule. That's why this is the meaning of same liquid molecules attraction between like molecules. Here, the attraction between unlike molecules. That's why you call it like molecule and unlike molecule. Clear يا شباب?
Clear.
Okay, what's the meaning? What's this?
Viscosity.
Viscosity
What is viscosity?
is the ability for the fluid to resist flowing.
Right. The meaning of viscosity is here. Read this.
Resistance to flow.
Resistance to flow.
Give me a good example of viscosity.
Honey.
Honey.
Honey and
Honey.
honey and Water.
Lava, maybe.
Which is more dense, honey or water?
Water.
Honey.
Honey.
Dense.
Which is more viscous?
More viscous honey.
Definitely.
Honey.
Honey.
Definitely. Which one will flow faster? Water or honey?
water.
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 Exactly. If you put it in a tube, it will go by itself. It will move. But honey will not move easy. Good. Okay. Also, we read this. Volatile. What's volatile means?
أتذكرها بالعربي معناها متطاير.
Not, what is it in action, not متطاير. Exactly. Volatile means متطاير. It will not stay. But what's happening? Liquid what?
Goes to gas.
Exactly. That's the volatile. Liquid goes to gas for the same molecule. All right. And that's why, again, that's perfumes and water. Which is more volatile, perfumes or water?
Perfumes.
How do you know that? How did you know that?
لأننا لما نستخدم البرفيوم على طول يختفي يتحول إلى غاز.
Not only that, you can smell it everywhere, right?
Yes.
Yeah, water has no smell, but if you put water, it will stay as liquid. It will not change to gas. And you will not, if it is even, or let's say something like, let's see, you will smell it, but not easy. If it's not volatile, it will not go everywhere in the room.
Sir, if you have a juice, it has a smell. Does it mean that it's volatile or not?
What again?
If you have a juice, عصير,
Yeah.
you can smell it, but
Sure, because there are certain volatile things in it. Yes, of course. Right. Good. All right. There is a relation between volatility and what do you think? The heat of the reaction. What's the enthalpy of the reaction? Of this reaction? Liquid goes to gas. We call this delta H, right?
Yes.
What type of delta H is this one?
Endothermic.
Yeah, but what type? We call it
Rate of
Delta H.
evaporation.
evaporation. Exactly. Is there a relation between delta H evaporation and volatility?
I think
Yes.
it's really increased.
Of course. The more,
It's
the smaller, what?
the smaller delta H, the more it's volatile.
Exactly. The smaller or less number, this means more volatile. Clear? Okay.
Mhm.
We can see
Yes.
this clearly. We can see this in this equation. There is a relation, which is this relation. I prefer that you know the name, but it's not very important. Calcius-Calipran equation. This relate, what's P here?
Pressure.
Pressure, which is the vapor pressure. Vapor pressure. Good. What is delta H?
Heat of vaporization.
Heat of vaporization, exactly. What's T?
Temperature.
In what unit?
Celsius. Or Kelvin.
No, of course not. In what?
Kelvin.
Always Kelvin.
Kelvin. All right. And what's R?
Gas constant.
Gas constant. Give me the value of R.
0.0882.
0.0. Look at the periodic table. 0.0 what?
82.
821. Why did you choose this R?
Because it is a fluid.
No, because of the unit here. What's the unit?
Pressure, so
Joule.
ATM.
No, the unit is
Oh,
joule.
Joule.
Look at your periodic table, just R from your periodic table. Which R you're going to choose? You're going to choose. No, not this one. Sorry. That's
It's not
wrong.
joule. Liter times ATM.
That's fine. No, I mean, which R should I use?
I think
8.31.
8.31.
I see. I don't remember it myself, but I should use this one, which is what's the unit? The most important thing I'm concentrating is what?
Joule.
Joule. Why did they
Joule.
choose the one with joule?
because it will cancel with the heat of evaporation.
The unit for delta H is what? Joule or
Joule.
kilojoule?
Joule.
Clear?
Clear.
Good. When we develop this equation, we will reach to this equation. I want you to memorize this equation. Oh, by the way, yes, one more thing. Memorize this equation very well. What is this thing? Len.
Natural logarithm.
Natural logarithmic.
Log with base 10.
Logarithm. Natural logarithm. You can find this in your calculator, right?
Yes.
Right? Good. Now, let's solve this problem. Read and solve this problem. I gave you the equation in here. In the exams, I'm not going to give you this equation, but you should know how to use it. What's this equation says? Vapor pressure of diethylether is 401. What's the 401 in this case?
P1.
P1. Okay. What is 18 degrees C?
This is T1.
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 Good. And molar heat of vaporization is 26. What's
Delta
this?
H.
Is it delta
Delta
H?
H.
Okay. Calculate the vapor pressure at 32 degrees C. What's 32 in this case?
T2.
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 So what are we going to calculate in this equation?
P2.
B2.
Go ahead. Use your calculator. The equation in front of you. You have everything here. Don't forget which R you're going to use.
8.31.
8.31. The temperature must be in what?
Must be in
Kelvin.
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 And this heat, 26. What
Should
should
be-
I do?
In joule times it by 1,000.
Exactly.
Sure.
Go ahead. Solve the problem.
Pressure must be in ATM or
Should I change this to atmosphere or keep it?
I think the same.
Yeah, it is the same. Why?
It's P over P.
P over
They
P over
cancel
P.
each other.
Over P. So if this is millimeter Hg and this one is millimeter Hg, what will happen to them?
They will cancel each other.
They cancel.
So if it is millimeter, your answer must be millimeter Hg. If it is atmosphere, then your answer should be atmosphere, and so on and so forth. But you don't have to change it. Clear?
Clear.
Okay, go ahead. Tell
yeah,
me
clear.
about P2. Use your calculator. Let me ask you another question. Do you think the number will be similar to 401 or bigger? So P2, is it going to be similar to 401 or higher or less?
I think higher.
I think it will be higher.
Is it 6 point?
Doctor, your voice is not here.
You are muted, doctor.
دكتور يعمل الو
Hello, السلام عليكم.
Yes.
السلام
عليكم السلام.
Hello, سمعوني يا شباب؟
إيه الحين
إيه بس
أيوة
قطع.
سمعك.
Problem. Okay, so my question is, which one is going to, according to this problem, which one is going to be bigger, B2 or B1?
B2.
B2 is bigger than B1.
B2.
Why?
Because the heat increased.
If you increase the heat, the vapor will increase, right?
Correct.
Yes.
Okay, good. Did you solve this problem? What's B2? Surah, calculator.
I got 471. I'm not sure
No,
about
no,
the question. Yeah.
no. لا تنسون تغيرون تي إلى كلفن.
I got 665.
Good. Somebody got 665 millimeter Hg. Anybody else?
Same answer.
56,
Yes.
sorry.
What?
56, not 65, sorry.
656.
No problem. 656 is the correct answer, and I hope you know how to do it. There will be a question in the next quiz, inshallah, exactly similar to this one. The numbers are different only. Clear, يا شباب?
Clear.
Very good. Be ready for it. Good. We're done. Next, we're talking here about what? Liquids, right? Now we're going to talk about solid. We're going to talk about solid now. Solid. And the first word we're going to talk about is crystalline solid. What's the meaning of crystalline solid? Crystalline means ordered. What do I mean by order? Look at this picture. Is this very well organized?
Yes.
Yes.
Very well
Yes.
organized, right?
Mhm.
This is crystalline. Crystalline means very well organized. And in the crystalline, we have what's called unit cell. Unit cell. What's the meaning of unit cell?
It is
That's
like the
not-
base that is repeated.
Exactly. So if you repeat the unit cell, what will happen?
You will get the
All structure.
Crystal.
whole structure. Yes.
Exactly. And then what's the unit cell? Read it here.
Basic repeating structural unit of a crystalline solid.
You got it?
Yes.
Next, very important word I want you to know, lattice point. What is the lattice point? Let me take this, erase. What is lattice point? These are lattice points everywhere. What's this?
Those are lattice points.
These are the corners of the lattice point. Now, this is called unit cell. Now, we have many unit cells. All of these unit cells with different names. We have what's called simple cubic, tetragonal, orthorhombic, rhombohedral, monoclinic, triclinic, hexagonal. Don't memorize anything of all of these except one, which is this one I care about and I wanted to know. What is this structure called?
Simple cubic.
Simple cubic.
Yeah, but in this case it's simple cubic, but it's actually cubic in general. Cubic. What's the property of cubic?
All the rods are the same length.
It should have same length.
Yeah.
A equal to B equal to C. What's that mean?
The distance between each lattice point is the
There is
same.
A. This is A, this is B, and this is B. This means all the distance are
The same.
the same. What is alpha and beta and gamma?
The
90.
angles,
The angle in between the faces is what?
90, always the same.
Same. Exactly. That's, I want you to know only this one, and this one. Don't look at them even. Clear يا شباب?
Clear.
Clear? Good. Now, when we pack things, actually, we don't pack it like this. We don't put it like this because the atoms are touching each other. The atoms here are touching each other. And that's why actually this is the shape of the cube. And the atoms are touching each other. Clear يا شباب? I want to ask a simple question. What do you think this distance in the simple cubic is equal to what?
The radius of the lattice point.
Is it the radius?
Together, yes, it's the radius, but each one
The
is
radius
half the
multiplied by
radius.
2.
Yes. No, each one is the radius. And the total is the diameter, if you want. If it's the same atom. Exactly.
2R.
2R, yes, 2R, not. So yes, very good. So this distance is 2R in this case. Okay, good. Next, I want also to define what is coordination number. What's the meaning for coordination number? Is the number of atoms around the main atom. How many atoms are around X?
9.
9 atoms, exactly. Is it 9? Count them.
Oh, 8.
There are 8 atoms. It is the X is number 9, but actually there are 8 atoms around the atom. Clear? Now, the coordination number, you cannot see it very well here, but if you have layers of atoms, this is how things, if you put them together, what's the coordination number for the yellow, the yellow atom? If you put this one above it and this one below it, what will be the coordination number?
12.
And how about this time? Also 12. Can you see it? So the
Yes.
coordination number is 12.
Some of the
Good.
balls.
Now, also, we have 3 types of cubes. We have 3 types of cubes. That's I wanted to memorize. We said, which one is the crystalline structure that we care about?
The cubic.
Only cube. Cubic. Okay, good. We have 3 cubic structure. We have what's called primitive cubic, body-centered cubic, and face-centered cubic. The primitive cubic is the lattice point are occupied with the atoms, like this one. Okay, and the body-centered cubic, in the cube, in the middle of the cube, there is one atom inside. All right?
Yes.
And the face-centered cubic, each face, if this is the face here, I took one face only, there is 1 atom, 2 atom, 3 atom, 4 atom, and there is 1 in the middle on the same face. And that's called face-centered cubic. Good?
Good.
And now, when we pack the atoms, we call them close packing. Close packing. Close packing. Close packing is putting things close to each other like this. This is what's close means, very near, right? And what's packing? What's the meaning of packing?
Putting them on top of each other. Layers.
Arabic.
مجموعة أو تجميع.
تعبئة. When you pack your luggage to travel, what do?
عبي.
عبي شنطتك عشان السفر. You can pack your ودائما إذا أنتم رحتوا المطارات على أساس يتأكدون بيقول لك did you pack your luggage yourself؟ يعني هل أنت عبيت الشنطة حقك yourself؟ Clear? So what is close packing? We put the atoms together like this. We have 2 types of close packing. Okay, we have what's called hexagonal close packing and cubic close packing. Okay, what's the difference? The difference is this structure. This is hexagonal close packing, and this is cubic close packing. We put 3 and then we put 6, and not 3, we put many of them, but we can see the 3. And look, what's the difference between them? A and A are in the same direction. And that's why the packing in cubic close packing is AB, AB, AB. But look at C. look at cubic close backing. A and C, what happened to them?
They are different.
They are rotated around each other, right?
Yes.
In this case, we pack A, B, C, A, B, C, A, B, C. لما نعبيهم. What's this? Read this.
Hexagonal close
pack.
backing.
How do we pack it? A, B, A, B, A, B, A, B. Clear? Read this.
Cubic closed pack.
And how we back it?
A, B, C, A, B, C, A, B, C.
C. And that's why, okay, look at this one. Now, if we put blue, red, blue again, what's this called?
Hexagonal.
And then we put blue, red, and then yellow. They are the same atoms, but we put them in different color to differentiate. What's this called?
Cubic.
Cubic close.
Obviously. Now, when you do that, you will find that hexagonal close backing is the body-centered cubic. And cubic close backing is the face-centered cubic. Clear? You have to know
Okay.
this. Good. Next. Actually, the atoms are touching each other like this. So we are going to call the distance from here to here, we're going to call it A. What is A in this case? The side of what?
Side of the cube.
The cube. If the atoms are touching each other like this, what is A equal to?
2R.
Why?
Because each atom has the radius r, and they are touching each other. So the distance from one center to another is 2R.
If we have body close backing, then A will be equal to this value. And if we have face-centered cubic, this face-centered cubic and body-centered cubic, and this is simple cubic structure. Okay. Then we have this relation. What I did, I made this table for you, which is not available in the original structure, but I want to tell you this table is extremely important. Extremely important. Clear, ya shabab? How many cubic structure we have?
3.
What are these?
Simple, face-centered, and body-centered.
In the simple cubic, okay? Let me go back to this one. Let's go to this one. How many atoms are available in this simple cubic?
4.
How many atoms in this cube?
4.
No, there is only one. Why? Because the cubes are touching each other everywhere. It's like this. Can you see the structure here?
Yes.
Okay. Now, if we go to this one, look careful now. In the simple cubic, how many cubes? Let's concentrate on the one with the red point. How many cubes will share this point? There will be a cube here, right? Right?
Yes.
A cube in front of it. In this side, it's in front. And in this side, and there is cube up there. There is a cube there, and above it, there is another cube like this. right? So how many cubes are sharing now this point?
4.
4. And put above them 4. Put in front of them also 4. Because they will share this one, right?
Yes.
So how many cubes will be sharing the same point?
8.
8 cubes will share this one with x. So this x is giving 1/8 to each cube. So that it's 1/8 times 8, because we have 8 atoms. 1, 2, 3, 4, 5, 6, 7, 8 times 1/8. There will be 1 atom per cube. Clear يا شباب? In the body center, this one, there will be 2 atoms. I'm not going to explain it, but if you sit down at home and study it, you will be able to do it. 2 atoms per cube. And in the face center, how many? We have 4 atoms per cube. واضح يا شباب?
Yes.
I put this in this table. So I just simply want you to memorize this table. Write it now. Write it in your notes, because I will give you a problem in a while. Okay. In the simple cubic, how many atoms are there in the cube?
1.
1. In the face centered cubic?
4.
Hello? 4.
4.
In the body centered cubic?
2.
2.
The relation between R and A, which we just saw a while ago, which is this one, we can rewrite it to make it like this. R equal to what?
A over 2.
What's R equal to here?
A root 2 over 4.
Exactly. A root 2 over 4. Of course, this is very simple, right?
Yes. A over 2.
You could take it here. A equal to 2R, so R equal to what? A over
2.
2. As simple as that. You remember it. But this one, you will not remember it. And that's why I want to tell you how to remember it. It's A, again, over 4. But instead of root 2, what is it?
Root 3.
3.
Doctor,
Yes.
we have to memorize this table, right?
Yes.
Thank you so
Exactly.
much.
Memorize it fully. واضح?
واضح.
What is the 1 and the 4 and the 2? What's this?
Number of atoms
In where? In the cube.
in the cube.
Exactly. And what's R?
Radius of
Radius of
one
what?
atom. Of the atom.
Radius of 1 atom. Exactly. And what's A?
The side of the cube. The length of the
Side.
side.
Side of the cube. What's the volume of the cube?
A cube.
What's the volume?
A times A times A. So A cube.
A cube, or A to the power of 3. Exactly. Clear يا شباب?
Clear.
Clear? Okay. How do we calculate the density of the cube? What is it?
The mass.
Mass
The mass
over
over
volume.
Mass over volume.
Over volume, exactly. So if I give you A, can you calculate the volume?
Yes.
If we have the mass, we will.
How? Yes. If you know the mass, how do you can tell what's the mass in the cube? By the number of atoms, exactly. Right?
Yes.
And how can I calculate A from the volume?
It's the
Cubic, bro.
cubic root of volume.
Just a cube, or no? All square root.
Yes, or like this. Clear, يا شباب? Now, if I give you a cube now, one cube, and tell you it is face-centered cubic, then naturally, how many atoms are there in the cube?
4.
Four.
Four.
4 atoms. Okay, how can I tell what's the mass of these 4 atoms? Let's say that I have gold atoms. How many atoms are in face-centered cubic of gold?
4 atoms of
Four.
gold.
What's the mass of these 4 atoms?
4 AMU.
4 what? 4 AMU, wrong. 4 times what?
Molar mass.
Molar
Molar
mass.
mass.
What is molar mass of gold?
It is AU, right?
Yes. What's the unit? AMU. But what's the number? Give me number here.
196.97.
96 AMU. How can I change this to gram?
Divided by Avogadro
By
number.
Avogadro.
Divide Avogadro number.
Exactly 6.022 times 10 to the power 23 AMU is 1 gram. Okay, solve this problem. What type of cube is this one?
Face centered.
So how many atoms do we have?
We have 4.
4. Okay, now what's this?
Density.
Density. Density. Can you calculate the volume if you know the mass and you know the density? Can you calculate the volume?
Yes.
Yes.
Okay.
Volume
but
equal
how-
mass over density.
Exactly. Okay. Find first the mass of the cube. What's the mass of the cube?
1.31 times
Just
10
a
to
second.
the power.
Just a second. It's 4 times what?
196.97.
Exactly. Times, I want it, now this is AMU. What should I do to make it in gram?
Divide.
1 over 6.022 times 10 to the power 23.
And you have the answer in gram. Good. So you can calculate it. Go ahead. Done يا شباب?
Yes.
What's the volume?
The volume is 1.31 times 10 to the power minus 21. Oh, الفوليوم. أفكر الماس. لحظة.
Oh, this is the mass. Sorry. Yeah,
This is the-
this is mass, the volume over, this is in gram now, over density, which is divide by 19.3 gram per
Per
centimeter cube, and you have the volume. What's the volume?
6.78 times 10 to the power minus 23.
6.78 times 10 to the power.
Minus 23.
Minus 23.
Who else? Did you get the same answer?
Yes, I got
Because
the
I don't know the answer. It's not in front of me now. Okay, so volume is this 1 centimeter cube. Okay, how can I change it to meter or angstrom? Let's change it to angstrom right away. What's the relation between centimeter and angstrom?
One
You know,
times
1 meter is equal to 10 to the power 10. What?
10 to the power 8, yeah.
Exactly, 1 times 10 to the power 8. How many? Okay, find the volume now in angstrom. Or let me make things easier. خلونا, now, before we go to this, can you find what is A by centimeter actually? What is the value of A? This is volume, right?
Yes.
Now, can you find A? What's A equal to?
Cubic root of volume.
Okay, give me the answer in centimeter.
Put it in angstrom.
No, let's have it in first in the centimeter, please. 6.78 times 10 to the power minus 23, and then take the square the cubic root.
Okay.
4.1 multiplied by 10 to the power minus 8
Minus 8, what? Centimeter.
centimeter.
Now, change it to angstrom. What's the answer?
Four point
4.1.
Angstrom. Exactly. Because times 10 minus 8 times 10 to the power plus 8, it will be 4.1 angstrom. Is this easy?
Yes.
Yes, yes. So this is the second question. It is 4.44. How come you got it wrong, by the way? The answer that you gave me is wrong. Oh, this is A.
Zara, let's say.
He wants the radius. Yeah. correct.
Now let's go back to the table that I gave you and
What's the
calculate
radius?
what's R. Yes. Don't forget. What's the relation between R and A?
A root.
Root of
2 over 4.
exactly. Okay, calculate A then. Calculate R.
One point four four.
1.44.
Or
This is
1.45.
Oh yeah, 1.44. This is the second question in the next quiz. It will be very similar to this one. You have to solve it. I will mainly change the numbers. Can you understand? Do you understand this now?
Yes.
Okay, let's stop here. I will stop at 11.4. Good. I hope you remember this very well. And inshallah, see you after the vacation. Okay, let's close this one.